All right, this is going to be the last video of the first week. So in this video, we're going to study the second example of chapter 15 in Musgrave-Winston Green that concerns consumption and production at the same time. So it is called one consumer and one product economy, or Robinson Crusoe's economy, right? So we are going to incorporate production into the model. In the previous model, in pure exchange economy, there was no production. So the only issue we have to consider was how to distribute endowments for two consumers, right? But now we are going to take into account the production process. So we are going to borrow some toolkits from producer theory. That is covered in chapter 5 in Musgrave-Winston Green. So we can describe firm's technology with a production set. Production set is defined as the set of all feasible production plans. So that is the set of vectors. So set of goods. So here from y1 to yl, and such that f of y should be lower than or equal to 0. Okay. So it is convention to write if y sub k. So the kth good is an output. So that is produced by this firm, and we put this as a positive number. And if the firm uses y sub k, kth good, as an input, then we label as a negative number. So in this production plan, positive number represents an output, and the negative number represents an input. So if we go back to intermediate class of microeconomics, firm's technology is usually described by production function, right? So we studied this kind of function in undergraduate level. So let me write Q for output. Q, right? So production function means if the firm uses labor and capital, then this shows us the highest possible level of output firm can produce given these two inputs, right? That is a production function. But that is appropriate if the firm produces one homogeneous good. Okay. On the other hand, many firms, in particular, conglomerates produce multi-products. Conglomerates produce many other stuffs, not homogeneous, but many other different products to the economy. But with that technology, so for the technology of conglomerates, we can describe its technology as with a production function, because to be a function, the function's value should be one-dimensional, some number-way object, right? But with this production set, we can describe such a conglomerate's production technology as well. So suppose if I use if I spend 10 hours, I can write, say, one paragraph of a paper, one paragraph, or one sentence sometimes if I'm not a good condition, or I can produce, and I can produce, say, so I can record this kind of lecture for 2 hours. Okay. So with the 10 hours, I can write one paragraph of paper and 2 hours video lectures. That is my production function. For instance, I can produce two different objects, paper and lecture videos, right? And this kind of multi-products cannot be described by production function, but with a production set, we can easily describe such a technology as well. All right, so that is a production function. If one firm has one input, so uses one input to produce one output, then we can describe this production set on the XY coordinate system. Then once again, output is a negative number. So let me call this Z. So one input, okay, and output is a positive number. Then the production set is going to be like this. Okay. So it appears second and third quadrant of the XY coordinate system. Cool. And then we call that this frontier production frontier or transformation frontier, right? So just as budget set separates commodity space into two regions, so the set of affordable bundles and the set of non-affordable bundles, this production frontier separates input and output space into two separate regions. So the set of feasible plans and set of infeasible plans. Okay. So the shaded region denotes the set of all feasible plans, and the outside region is non-feasible plans. Okay. All right. So production frontier, and we can define profit function. So given price vector P, so here P vector denotes a price of each good. Okay. So the collection of prices of each good, and the production set Y, we can define profit function as the highest profit the firm can achieve given these price vectors. So the accounting profit can be defined as the dot product between price vector and the production plan. And then the firm chooses production plan so as to maximize this accounting profit. Then we can describe it as a function of price that is called a profit function. All right. So one property of this profit function that can be easily derived is this function is homogeneous of degree 1, right? That can be easily seen. So once again, pi of p is defined as max of p dot y, okay? And suppose we scale up price by multiplying constant lambda. Here lambda is a positive number. Then by definition, this is going to be lambda p dot y, okay? And because this lambda is a constant, so we can pull it out and put it in front. So then it's going to be lambda times max p dot y, but max p dot y is the original profit function at price vector p. So we can easily see profit function is homogeneous of degree 1. All right. So I guess this is almost everything we need to proceed this Robinson Crusoe's economy. All right. So now let's go to the next slide. So the next slide introduces model. So we have two components or two problems because now we consider consumption and production at the same time. So to introduce production in the simplest possible setting, we consider an economy with two price-taking agents, one single consumer and one firm. Okay. So now we have to consider firm's problem and consumer's problem. Let me first illustrate firm's problem. So firm produces homogeneous goods, right? So we don't have to think about multi-product. Suppose for easy exposition, we are going to focus on the firm producing only one homogeneous good. And the firm uses only one input, Z, okay? And here Z stands for labor. Then accounting profit is gonna be, so here given price vector, P is the price of the product, okay? The market price of the product. So the unit price of the, it's a unit market price of the product. And the W stands for wage. So wage per hour. Then if the firm hires Z hours, then it incurs a cost as much as WZ. Okay, so we need to subtract away that cost from the accounting profit. And the firm's revenue is P times Q. So we have a expression for accounting profit, and the firm wants to maximize this. But this plan, negative z comma q, once again, z is an input, so we usually put negative sign in front. So negative z comma q should be feasible, so should be an element of the production set y. Okay. So because we have one input and one output, so small f of z, so we assume small f of z production function stands for this production technology, right? And in such a case, y production set can be written as negative z comma q, such that q is a lower than f of z. Okay, because production function f indicates the highest possible quantity, the level of output, right, can be produced by this firm. So the output for this production plan for to be feasible, output cannot exceed f of z, given input z, right? So only this combination z and q satisfying this inequality are gonna be feasible, right? All right. Okay, then so maximizing over production plan gives us a profit function given price vector p comma w. Cool. And they suppose this firm is owned by that single consumer. Okay, so in fact, in this economy, there is only one agent, and this agent engages in consumption and production at the same time. You know, in reality, firms are owned by several consumers or several households. Okay, but you know, for simple analysis, we are going to assume very unrealistic economy. Okay, so it may sound odd, but our aim is to develop insights that can be extended to a more complicated and more general framework in the end. So so bear with us. I mean, we are going to generalize this framework, but our current objective is to develop insights from this model. So what happens if we if we incorporate production into the economy? Then you know what further issues we have to consider. That is going to be the main topic of this video and the main topic of this second example. All right. So now we describe firm's problem. Now going to consumer's problem. Then given price vector p comma w, consumer wants to choose one bundle, x1 and x2, that maximizes his own utility. So utility function, you have x1 and x2 should be maximized given one constraint, all right? So here basic constraint. So here x1 stands for leisure, okay? And x2 stands for the good produced by the firm, okay? So in this economy, there is only one homogeneous good, okay? And consumer has to decide how to distribute, how to allocate his time on a leisure and the labor supply to the firm, okay? Otherwise, the firm will stop because the firm uses only that labor as an input, so there will be no production. Okay, so this consumer has to decide how to allocate his daily time. That is given by L bar. So L bar can be thought of as 24 hours or 16 hours, except sleeping hours. So given his total hours per day, L bar, how to allocate this L bar, to leisure or a labor supply. Okay. All right, and in this case, we can write the basic constraint this way. All right, so L bar minus x1, because x1 was a leisure, so L bar minus x1 is going to be labor supply. Okay. So total hours for working by this consumer. And then if we multiply the wage, that is a wage per hour, then we can think of the first term of the right side in this velocity constraint as labor income. Okay. And furthermore, this firm is owned by this consumer. So this consumer has 100% share of this firm. So additionally, this consumer earns profit pie from this production. Okay, so the total income is going to be this. Okay, and this total income will be spent on consumption of a good too, and because P is a unit price of that good, so P times X2 is going to be total expenditure. So the velocity constraint can be written this way. All right. If we rewrite this velocity constraint by moving x1 term on the right side to the other side, then we have this wx1 plus px2 should be lower than wl bar plus pi p comma w, right? And then so we can think of this w, wage per hour, as the price of leisure, because a W can be thought of as a opportunity cost of leisure. If he idles away for 1 hour, then he will lose the chance to make money as much as W. So this is so this expression also makes sense. All right, so anyway, this is a consumer's problem, all right? So now we have to solve out these two at the same time. So let me first illustrate how to analyze firm's problem. That is easy because in order to maximize profit, so the original problem was this, WZ, okay? But in order to maximize profit, so if the firm hires a Z, that is a demand for labor, then it has to produce as much as F of Z, okay? Remember, function F stands for the highest profit or highest amount of, so the highest level of output can be produced with input Z. So in order to maximize profit, first it has to maximize revenue given input. So the Q can be replaced with F of Z, right? Then we can rewrite the accounting profit as a function of Z only, given price vector. So we can take the derivative to find the first order condition. So Pf prime of Z minus W and set it equal to 0. Then this is a first order condition for profit maximization, right? So it can be rewritten as P comma W, that is a price vector, and using dot product, so price vector dot F prime of Z minus 1, okay? And this highlighted first order condition can be written as the dot product of these two vectors. And if the dot product yields a value of 0, that means these two vectors are perpendicular, right? So at the profit maximizing production plan, price vector and F prime, that is gonna be, so F prime and -1, that's gonna be slope of the this production frontier, right? So at the profit maximizing point production plan, price vector and the slope of this frontier should be perpendicular like this. Okay, so another geometric way, another way to interpret this first order condition geometrically is this perpendicular condition between price vector and the slope of the production frontier. All right. So now we can derive a profit function. Okay. So suppose Z star Z star solves this equation, first order condition. So Z star is gonna be optimal input, so optimal demand for labor, right? Then the profit function pi of P comma W is gonna be P times F of Z star minus W Z star, right? W Z star. And then let me call this F of Z star as Q star. Okay, in order to separate Q and Z, because we describe everything on the plane Z and Q. Okay, and now from this profit function, this profit function, the coordinate of y-intercept is can be easily found. So the y-intercept means z star is given by 0, right? Then the q star is y-intercept. The coordinate of y-intercept is going to be profit function divided by p. Okay, so the y-intercept indicates the level of profit and divided by price. All right, so this is a firm's problem. Now consider consumption problem. Okay, and to maximize utility, the consumer enjoys leisure x1 star and consumes the good x2 star. Okay. Okay, so let me draw one more picture here. Okay, so the consumer's velocity constraint was px2 lower than, wx1 plus px2 should be lower than wl bar plus pi. Okay, and we already figured out the profit function from the firm's problem. So given that profit function, we can draw indifference curve and this Volagen line on the plane x1 and x2. Okay, but x1 cannot surpass L bar. Okay, a consumer has a limited time per day, L bar. Okay, so if he enjoys leisure, if he enjoys leisure for full day, so x1, if x1 is L bar, then what happens? X1 is L bar, then these two will be cancelled. So x2 is gonna be profit divided by p. Okay, so the Volagen line should pass through this point. Okay, and now think about the intersection with this vertical axis. So now, what if x1 is a 0? And x1 is 0, then x2, the maximum consumption of the good is WL bar plus profit divided by P. Okay? So clearly this point is going to be higher than this point. And then we can draw these 2 points to find the Volagen line. Okay? Yes, so the exact graph of this Volagen line, of course, extends to this region, but we don't have to consider this region because that is, naturally infeasible. All right, so we are gonna restrict attention to this region, and then optimal choice is gonna be determined where his indifference curve is tangent to this blue line. Yeah, so this point indicates the optimal choice of x1 star and x2 star. Okay, so optimally, consumer is going to enjoy leisure as much as x1 star. So the remaining part, L bar minus x1 star, this portion captures a labor supply, optimal labor supply to the firm. Okay, and just as we combine two problems. So in pure exchange economy, we had two consumers problems, and we combined that with a attribute box. We can do a similar job here. So this is a consumer's problem, and this was a firm's problem. Then we can combine these two graphs in this way. Okay. So the firm's okay. So for firm's problem, the axis was this. Okay. That was right here, and for consumer's problem, the axis was right here. Okay. And then the axis in this figure are these two. Okay. So we combine these two to the extent that the length of the box is the same as the total hours for the consumer, L bar. Okay. Then we can describe a firm's production decision and the consumer's optimal decision for leisure and consumption in the same box. But that is an open box. There's no lead, but we can describe both in the same picture. So that is good. Okay. All right. So what is an equilibrium? Remember, to be an equilibrium, no economic values should change. If something changes, then that is not a stable status. So it cannot be seen as an equilibrium. Okay. So how do you define equilibrium in this economy? So Volagen equilibrium in this economy involves one price vector P star and W star. Okay, so price of the good and the equilibrium wage per hour. So first, to achieve a stable status, consumer has to maximize utility. Okay, so the equilibrium allocation X star, given this price vector, must maximize the consumer's utility. Otherwise, the consumer will change his consumption plan. The consumer will deviate, so that's going to be non-equilibrium. At the same time, the firm's choice of labor supply, C star, the choice of input, should maximize the firm's profit. Otherwise, the firm will revise its supply schedule. So something changes as well. Okay, so not an equilibrium. Right? And the third condition for equilibrium, consumption market must clear at this price vector. Okay, so it can be written as, because demand for the good is a x2 star of price vector, equilibrium price vector. So at this equilibrium price, that denotes the optimal demand for the good. Okay, so the demand for the good should be equal to supply. So Q star of P star and W star. Okay. If that condition is not met, so for example, the demand is larger than the supply, so there is a excess demand, then we can easily anticipate the price goes up. P star will adjust to the extent that this demand and supply are balanced off. Okay, so something changes. Right? If the other way around, so if the inequality was reversed, then there will be excess supply. In such a case, price will now decrease. Okay? So at the equilibrium, price must adjust so as, to the extent that this demand and supply should be equal to each other. Okay? For the same reason, labor market also clears at the equilibrium price. So the labor supply, that was a so that was a L bar minus X1 star. And demand for labor, Z star. So demand by the firm should be equal to each other at the equilibrium. Otherwise, now the wage will adjust. Wage will change. Okay, so not an equilibrium. All right, so the equilibrium characterized by these four conditions. Yeah? So going back to the previous slide, this status cannot be an equilibrium because at this, so in this picture, think about the labor supply. Labor supply is gonna be this portion, L bar minus x1 star, right? But a demand for labor is this, right? Because the firm's axis was this Q vertical axis, and this horizontal axis, right? And the firm is willing to choose this production plan, right? But to achieve this production plan, the firm has to demand as much as the labor as much as this. Okay, so there will be excess demand for labor. Okay, and for in consumption market, consumer is willing to demand this amount of good. Okay, but the firm produces this amount, right? This amount. So that is a demand for the good, and supply of the good is like this. Okay, so there is a excess supply in a in the market in the market for the good. Okay, so it's not an equilibrium. So to be an equilibrium, we can easily see production plan, optimal production plan for the firm, and the consumer's optimal decision, optimal choice of leisure and consumption should coincide like this. Okay, and the equilibrium vector has to support these decisions, meaning that this price factor must be tangent to production frontier and the indifference curve. All right, so that so this displays Volagen equilibrium in this economy. Right. Okay, let's do one example here. So compute the Volagen equilibrium when the production function is given by z to the power 1/2, so square root of z, and utility function is Cobb-Douglas, and the total endowment of labor is L is equal to 1, so normalized to 1. And then how do you find the Volagen equilibrium in this Robinson Crusoe economy? Let me open a new note. So first we compute firm's profit function. So pi of p comma w is gonna be the highest profit. So p times z to the power 1/2 minus wz, right? So taking derivative with respect to z, we have p over 2 square root of z equals w. So that's the first of the condition. So optimal demand for z, we can obtain this z star by solving this equation for z. Okay, so, right, this is a p squared over 4w squared divided by 4w squared. Am I right? Okay, let me double check. Yes. Okay. All right. Because we know this profit function is homogeneous of degree 1, so let me label the relative price p over w as a I need another variable, so let me call this sigma. Okay, sigma. So that's sigma stands for the relative price. Sorry, W over P, because for a consumer problem, good 1, it was a leisure. So put the price of good 1 and price of good 2 on the bottom. Okay, so W over P is a sigma. Okay, then we can write this Z star as a 1 over 4 sigma squared. All right, and then profit function, pi of price vector is gonna be p times, all right, for the expression, it's better to use this expression. So for the expression of profit function, it's much better to go with this expression. So plug in that z star, then we have p over 2w and minus w z star p squared 4w squared. Then summarizing this, I think p squared over 4w. Yes. Okay. So now we have a profit function. Okay. Profit function. Then the basic constraint of a consumer is gonna be px2. So wx1, px2 should be lower than wl bar plus p squared over 4w. Okay. And then let me normalize this. So let me divide both sides by p. Then w over p x1, so sigma x1 plus x2 and sigma L bar. And then we first divide it by p, so the power of the numerator becomes 1. So p over w, that is 1 over 4 sigma, I guess. All right, and then the consumer's utility was a Cobb-Douglas, log x1 plus log x2. So given this basic constraint, the way to maximize utility is, because now the weight is 1/2 and 1/2. So this consumer has equal weight on leisure and the good, right? So with this weight 1/2, we know the optimal decision for the optimal choice for leisure x1 star is 1/2 times his income, so sigma L bar plus 1 over 4 sigma divided by the price. Okay, and the x2 star is a 1/2 times sigma L bar plus 1 over 4 sigma is income divided by, now we normalize the price of x2 1, so it should be 1. Okay, cool. Then now the only thing we have to find out is what is the equilibrium price. So from the now we went over the first two conditions of equilibrium. So now using the last two conditions, we can find the equilibrium price. Okay, so going back to note. Right, so x1, so 1 minus x1 star, that is a labor supply. Okay, so that is 1 minus 1/2 times, I can rewrite this expression as L bar. So L bar is 1. Okay, so 1, sorry, L bar was 1. What am I doing now? So this is 1, and this is 1, and this is 1 in this problem. So 1 plus 1 over 4 sigma squared. Okay, so 1/2 minus 1 over 8 sigma squared. It should be equal to demand for labor. The demand for labor was, 1 over 4 sigma squared. 1 over 4 sigma squared. All right, now I can see the end of this drawing algebra. I mean, unfortunately, general equilibrium entails this kind of some computational work. So that's why I don't like this topic. But yeah. So now we equate demand with the supply to find a equilibrium price sigma. Then 1/2 equals so 1/8 plus 1/4 divided by 1/sigma squared, and this is a 3/8, right? So 1/sigma squared is 1/2 times 8/3, so 8/3, which is a 4/3. So sigma squared is, now we flip the top and bottom, 3/4, so sigma should be positive number, square root of 3/2. All right, so we found the equilibrium price that which clears the labor market. And similarly, we can check whether that price, that sigma, clears the market for the good. So now this is a demand for the good, and where is the supply? Supply is, because a z to the power 1/2 is a total supply. So Q star is P over 2W. Okay, so equating this supply, equating that supply with this x2 star, you can easily check the same, equilibrium price clears the market. That is not a coincidence, just as we saw in the pure exchange model. It's going to be very general result, the so-called Wallace law. Okay? So if we found that one equilibrium price clears one market, clearing one market, and that price automatically clears the other market, right? So you can easily verify this price clears a market for the good as well. All right, and that is a so Volagen equilibrium is the answer is so sigma P star over W star over P star turns out to be square root 3/2. All right, then you can find the x1 star and x2 star. That should be same as so this one should be the L. Okay, x1 star must be equal to, because L bar minus x1 star, so for the L bar was equal to 1. All right, so 1 minus x1 star is equal to z star. So x1 star should be equal to 1 minus z star. And the next star should be equal to q star. Okay. So we can identify all numbers this way, equilibrium price. Then we can identify optimal choice for leisure and optimal choice of consumption. And from that, because two markets must clear at this equilibrium price, we can identify supply side as well. Okay, so that's the way to find an equilibrium. All right, and finally, we can derive. So we can study welfare properties of Volagen equilibrium. So we can derive two versions of welfare theorems. First, first welfare theorem states Volagen equilibrium is efficient. Okay, but if we think about efficiency in this economy, because we have two different sides, consumption and production. In the previous economy, pure exchange economy, we just had a consumption side. Because now in this economy, Robinson Crusoe's economy, we have two different sides. So we have to check whether production is efficient. At the same time, we have to check consumption is efficient. All right. So, but from this figure, efficiency is quite evident because a market allocation gives us 1 point on the production frontier. Okay, so efficient production means that if the equilibrium chose some point inside, so some point below this production frontier, then this firm hires too much input unnecessary. So this production plan is not efficient. So to be efficient, plan should be on the frontier, right? Then there is no other way to increase output without increasing input, right? But the equilibrium gives us a production plan on the frontier. So production side efficiency is achieved. Okay? And on the consumption side, because given this a production plan and given this budget constraint, consumer maximizes his utility. So there is no other way to increase consumer's utility. So a consumption efficiency is also achieved. Okay. So this is why Volagen equilibrium is parity efficient in this economy. So the first welfare theorem holds. Okay, and if we think about the second welfare theorem, then because in the pure exchange economy there were two consumers, so parity efficiency was defined as there is no other way to make both consumers strictly better off. If one consumer getting better off and the other consumer will be automatically worse off, that is a parity efficiency. But here there is only one consumer, right? So parity efficient allocation, it turns out that parity efficient allocation is a single point like this. Okay, so that is a unique parity efficient allocation in this economy because we have to. So the other way to see this is we have to consider efficiency on production side and on consumption side. All right, so in that open box, this was a production frontier. So the allocation for efficiency on production side, the allocation must be on this production frontier at the same time. It should maximize consumers' utility, right? So if we have this smooth production frontier and smooth indifference curve, we can anticipate the only efficient point, efficient allocation in this economy is a single point in this box, right? And that single point can be achieved by comparative market because we do have some separating hyperplane, separates this. So supporting the indifference curve, meaning that this blue line is tangent to indifference curve, and at the same time tangent to production frontier. So we do have a price factor supporting this blue point as an market equilibrium. So it can be achieved by market mechanism. That is what second welfare theorem states. So we can see the two welfare theorems are satisfied even in this economy. One more thing you can observe is Volagen equilibrium allocation is the same allocation that would be obtained if a planner ran the economy in a manner that maximized the consumer's well-being. Okay? If we think about this point, right? Because suppose that this economy is run by planner, right? Then there is no market mechanism. That economy is run by planner, right? So the planner without price mechanism, not relying on the price mechanism, market mechanism, and choose a one bundle, choose a one allocation in order to maximize consumers' utility, right? Then, given this technology, which allocation? So the feasible bundle is, this shaded region and this parity frontier. Then in order to maximize consumers' well-being, the planner will choose, because this utility level, it cannot be achieved given this technology. So the planner will choose this point where consumers' indifference curve is tangent to production frontier. That is the same allocation that can be achieved by market mechanism. Okay. So now we do not have a price factor. In market mechanism, we have a price factor, but if the economy run by a planner, okay, and planner does not have to determine the market price factor, okay, just to allocate the produced good, and they just let the consumer work as much as this amount, these hours, and so on, right? Without any pricing system. Then still, it can be, if the planner wants to maximize consumers' well-being, and we end up with the same allocation as the one achieved by market mechanism. Okay. And finally, the last point is convex technologies or convex preferences are necessary for the second welfare theorem, meaning that if a technology is a non-convex, then the second welfare theorem does not hold. Okay, may not hold. All right. So if we see that point, so here, consumers' indifference curve is convex toward the origin, meaning that consumers' preference relation is convex. But the firm's production frontier is not convex. Okay. Now now if we think about this set is a not convex set. So the production technology is not convex. Okay. In that case, all right. Here X star is a parity efficient, so that is an efficient allocation because this X star is on the production frontier, right? And it maximizes consumers' utility. So that is a efficient allocation. But if we think about this allocation can be achieved by market, then the market will determine that this price factor supporting this X star as an equilibrium. But if we think about, given this price factor, the firm maximizes profit by choosing this X star, the answer is no, because the firm can do better. Given this price factor, if the firm chooses instead of X, this point, some corner solution, then remember the Y-intercept of this line indicates the profit divided by price, okay? So we can easily see previously by choosing X star, the firm encounters a negative profit, but by choosing this point, the firm can improve a profit to some positive value, okay? So although this price factor supports this point, so this price factor is tangent to production frontier and consumers' indifference curve. So it looks like consumer and firms are maximizing their objectives, but the firm can do better by choosing the other points. So in market mechanism, this allocation cannot be achieved. Okay, so I think this video is a little bit longer than I had expected. Anyway, this is the end of the first week. So in the first week, we studied two examples of general equilibrium theory. Once again, that is an example. So all things we studied so far, the most important thing was a first and second welfare theorem. So whether equilibrium is efficient or not, and the efficient allocation can be achieved by market mechanism, we see that those two theorems hold in a very specific examples, but we are going to extend that insight to a more complicated and more general framework in the next week. All right. So, but before doing that, I have to do one more example in chapter 15. That is a 2x2 production model. So in the next week, I'm going to start with that example and then going to the next chapter. Right? Hope you guys enjoyed this video and this video is helpful. And just in case you guys have any questions about the course material, don't hesitate to stop by my office and then, yeah, we can discuss. All right? And have a nice day.